This video is for section 7.2, the sampling distribution of p-hat. And in this section, we're going to take a look at what happens when we take surveys involving proportions. So if we take a look at the example we have today, we have a polling organization. We're taking an SRS of 1,500 first-year college students, and we want to know whether they applied for admission to any other college. And we know the population proportion here, and that's not going to be something we'll usually know, but here we know that 35% of all first-year students did apply to colleges besides the ones they attend now. So what is the probability that our random sample of 1,500 students will give a result within 2 percentage points of the true value? So a couple things about this problem. First of all, we're given a sample size of 1,500, and we're also given the population proportion of 35%. Again, normally we won't have that number. For this problem, in order to explore it, we're going to act as if we do know that it's 35%. And we want to know the probability that we get within 2 percentage points of the true value. So what we want to take a look at here is, we don't know p-hat, but when we go out and take a survey, how likely is it that we get within 2 percentage points, between 33% and 37%? Certainly when we go out and take this survey, it's going to be unlikely that we actually get 35% of people to say that they went to another college or applied to another college. We might get 36% sometimes, 34% other times, maybe even as low as 32 or as high as 38%. So I want the probability that I'm within 2 percentage points of the true p. So for this problem, we need to know the sampling distribution of p-hat. So now we're going to look at the mathematical procedures for looking at the distribution of p-hat. So first of all, it's important to note that we have an SRS from a large population, and that's going to be needed for all of these problems. But just how large does the population need to be? Here we have a sample of 1,500, and the rule of thumb is that we need the population to be at least 10 times as large as the sample size. And that's going to be a common theme we're going to use throughout. So the idea here is, do we have a population that's at least 15,000? Well, we don't know the size of this college, and sometimes we have to assume things about our population, but here it's going to be safe for us to assume that our college is at least 1,500 students, and we can do the procedures in this section. So now we want to take a look at the sampling distribution of p-hat. So if we think about a distribution, there's really three things we need to know. We need to think about the center, the shape, and the spread, and once we have all three of these things, we'll be able to do our probability problem. So let's take a look at them one at a time. Oh, and first of all, before we go on to those things, a lot of the procedures you see here are things that you saw in the last chapter when we looked at the binomial distribution. Keep in mind that binomial problems can be modeled by using a normal approximation. And since we're just surveying people one at a time, and we can assume them to be independent, a lot of our things here can be considered binomial, and you'll see a lot of the same techniques and ideas going on. And also pay attention to the symbols that I use as we go throughout this section. So let's take a look at the sampling distribution of p-hat. First of all, we have to think about the center. The center here, the center of all p-hats, the center of the sampling distribution will be equal to p. Now notice the notation I use there. It is the mean of the p-hats, and that p-hat is a subscript here. If we were to take all p-hats, they would have a normal distribution. We're going to look at that later, and they'll center around p because p-hat is an unbiased estimator of p. We learned about that in the last section. That gives us some idea about the center of this distribution. Next, for the spread, we have a formula for that. This is going to be the standard deviation of p-hat. And here's the formula for it. It's the square root of p times 1 minus p over n. Now, we'll develop this formula in class, but it really does come from the binomial formulas that we learned in the last chapter. Now, it's important to note here, for the spread, we are able to safely use this formula when we have a large population, as long as the population is at least 10 times as large as a sample. And we saw in the last slide that we can assume that we have a large college here, so we are safe to use this formula here. Okay, and we'll be using that formula a lot in this section. Next, we need to think about the the shape of our distribution. So what shape will the sampling distribution of p-hat have? Well, we'll have an approximately normal distribution. And the reason for this really goes back to the last chapter. If n times p is greater than or equal to 10, and n1 minus p is greater than or equal to 10, then we are safe to assume an approximately normal distribution. So let's take a look at the numbers here. Well, n is 1,500 and p is 0.35, and 1 minus p is 0.65, So we plug into the formulas here, and I'm not even going to compute those numbers. I think it's fairly easy to see here that if I were to compute both of those numbers, they'd both be greater than or equal to 10. I'm definitely safe here, and I can assume that we have an approximately normal distribution. Also, that top formula would give us the expected number of successes. If we were to go out and survey 1,500 people, 35% of them agree with our survey. That would be the expected number of people I would expect to see agree with my survey. Conversely, the other one is oftentimes called the expected number of failures. Those will just be two different terms that we'll use for those NP and N1 minus P formulas. Expected number of successes, expected number of failures. So we have center, shape, spread. We have everything we need. We're all set to go. So let's plug the numbers in now. So the mean of the p-hats, the center of our sampling distribution, will be 0.35 because we know that that's p. The standard deviation of our sampling distribution, we have to plug into that nasty looking formula. I trust you can do that, and you'll get 0.0123 if you do all that. You want to go ahead and make sure you can get that in your calculator. And we also know that p-hat has an approximately normal distribution. So we have this nice little summary, and this essentially summarizes how surveys will behave if we were to take them repeatedly. They would center around 0.35, they would have this standard deviation, and we know that they would be approximately normal. So now we are all set to find and do our probability question, which is what's the probability that when we take our survey, we get one within 2 percentage points of the true proportion, which is 35%. Well, now this just becomes a problem from Chapter 2, all of our normal distribution stuff. So we start off by making a nice picture here, centered around 0.35. We shade in what we're looking for, between 33 and 37%. I am going to compute the z-scores here just as a little bit of practice. Keep in mind that z-score is what you want minus the mean over the standard deviation. So I'm finding the z-score for this end here. That comes out as 1.62. Usually we don't do that because we just cop out and use norm CDF most of the time, but it's not bad to note that this means we're 1.62 standard deviations from the center. So we're all set to go here. The probability that we get a survey that yields a result between 33 and 37% is the same as the probability of getting a z-score between 1.62 and negative 1.62. And really at this point I just go to my norm CDF on my calculator and I find that that is 0.8961. Another way to say that is that we have a 90% chance that a survey of 1,500 people that will give us a result within 2 percentage points of p, and that's pretty good. So a lot of these problems just come down to normal distributions. It's just knowing some new formulas and understanding some new ideas here, and we'll do a lot of problems in class. And there's also another example problem done as a video for you that you'll want to take a look at.